This lesson deepens the application of the Shore block concept learned previously. The child will experience that even when a block is not initially a Shore block, observing its relationship with surrounding boxes allows them to fill the entire block all at once. Here is our first problem for today.
Three, 3 is 2. Because row 4 makes 10. And if you add that one box, 3, 3, it makes 12. So 12 minus 10 is 2.
And then what?
I looked at the 3-box block that makes 10.
What made you look there?
Since we figured out 3, 3, we have fewer choices for the numbers, if we don't want to make a duplicate.
Did you check to see if your choices narrowed down?
10 can be 4 plus 4 plus 2, or 4 plus 3 plus 3. But we can't use 4 plus 4 plus 2.
Why not?
If we put 2 in 3, 1, it makes a duplicate with the 2 in 3, 3. So it has to be 4 plus 3 plus 3.
Try placing those numbers into the block that makes 10.
I'll put 4 in 3, 1, and put 3 in 2, 1 and 3, 2.
Initially, there were two possible sets of numbers, but determining 3, 3 narrowed it down to just one. Even though it wasn't a Shore block, the neighboring box allowed them to fill the entire block at once. This is the core objective of this lesson. At first, we had two choices for the numbers, but once we figured out 3, 3, it narrowed down to just one.
Yeah. Thanks to 3, 3, I could fill the whole block all at once.
What did you figure out next?
That 4-box block that makes 6 keeps bothering me.
Why is that?
Adding 4 numbers to get 6. That's a really small number. There probably aren't many ways to make it.
Try making 6 with 4 numbers.
1 plus 2 plus 3 is already 6. How can 4 numbers make 6?
Why do you think it can't?
If all 4 numbers have to be different, it will definitely be bigger than 1 plus 2 plus 3.
Do all 4 numbers really have to be different? Single guiding question. Do all 4 numbers really have to be different? Is sufficient. The child will naturally begin examining the block's shape. Wait patiently.
This block is in 2 different lines. So it's okay if we use the same number twice.
Why is it okay to use the same number if it's in 2 lines?
Because numbers only have to be different if they're in the same line. If they're in different lines, it's fine if they're the same.
Then, can you make 6 with 4 numbers?
3 plus 3 is 6, and 1 plus 2 is 3. So, 1 plus 1 plus 2 plus 2 makes 6.
Do you know exactly where they go?
I'll try putting them in, so they don't make a duplicate with the numbers I already found in columns 1, 2, and 3. there's a sure block. It's the block that makes 11.
Why is that a sure block?
The only way to make 11 with 3 numbers is 4 plus 4 plus 3. So I don't make a duplicate. I have to put 3 in 4, 1. And I'll put 4 in 3, 1 and 4, 2.
Do you notice anything else after filling in the 11 block?
2 boxes in row 4 are filled. Those 2 boxes make 3 plus 4, which is 7. Then 4, 3 and 4, 4 must make 3 together, right? I can figure out 3, 4.
How?
I just subtracted the 2 boxes from the 3 boxes.
Tell me your answer and make sure to use the word because to explain your thinking.
3, 4 is 3. Because 3, 4, 4, 3, and 4, 4 make 6 together. And 2 of those boxes, 4, 3 and 4, 4, make 3. So 6 minus 3 is 3.
Excellent! Where is the next box we can figure out?
I'll look at the block that makes 7.
Why is that?
Since there was only one way to make 6 with 4 numbers, I think there won't be many ways to make 7 either.
Why don't you check and see?
To make 7, it just needs to be 1 bigger than when making 6. So it's 1 plus 1 plus 2 plus 3.
Is that the only way?
1 plus 2 plus 2 plus 2 uses the same number 3 times, so that doesn't work. There's only one way to make 7, 2.
Why can't we use the same number 3 times?
Because the block that makes 7 is in column 1 and column 2. Even if we split the numbers into 2 lines, one of the lines will definitely get the same number twice.
Can you figure out exactly where they go?
I don't know which number goes where just yet.
Are there any other clues?
I should look to see if there's a place where I can use a 1-line sum or a 2-line sum.
Did you find one?
A place that gives a 3-box sum in 1 line is nowhere. And a place that gives a 7-box sum in 2 lines is nowhere either.
Are you looking at the blocks one by one?
I just need to find a place where they combine like Lego blocks to make 7 boxes, right? I found it. I know the sum of the 7 boxes in column 1 and column 2.
You found a box where you can narrow down the numbers, right? Tell me your answer and make sure to use because.
1, 2 is 2. Because the sum of the 7 boxes, except for 1, 2, makes 7 plus 11, which is 18. So I can figure out that 1, 2 is 2.
Can you write that as a math sentence?
It's 20 minus 18.
Try making the math sentence using the exact numbers on the grid instead of 18.
It's 20 minus parenthesis 11 plus 7.
Guide the child to interpret the expression using the language of relationships. Subtracting the sum of the blocks within the 2 lines from the total 2-line sum is the relational concept this expression conveys. This is a pivotal moment where they experience mathematics not merely as symbol manipulation, but as a language that expresses relationships. Can you explain what this math sentence means in words?
We are subtracting the sum of the 7 boxes inside from the total 2-line sum.
How did you find the sum of those 7 boxes?
I found it by adding the 3-box block and the 4-box block together.
One comma 2 is now determined as 2. Wait patiently for the child to look at the block that makes 7 again and predict, I think it will be different this time. If they don't offer this prediction, simply prompt them with, is there anything different now? Now, let's take another look at the block that makes 7.
I think it's going to be different this time.
What makes you say that?
Since we already know 1 comma 2 is a 2, won't that change what numbers we can use?
Let's check and see.
Yeah. Since there's a 2 sitting right there in 1 comma 2, there aren't many places left to put a 2 in the 7 block.
See if you can find the right place for the 2.
So it doesn't make a duplicate with the 2 in 1 comma 2. It can't be in row 1 or column 2. So 2 comma 1 has to be 2.
Did that open up another box you can figure out?
1 comma 1 is 1. Because 1 is the only number left in column 1. Now I just need to put in 1 and 3. And 3 has to go in 2 comma 2.
Why is that?
If I put 3 in 3 comma 2, it makes a duplicate with the 3 in 3 comma 4. So I have to put 3 in 2 comma 2. And the last one goes in 3 comma 2.
Wow! You filled all 4 boxes at once!
Yeah. It's all because we figured out 1 comma 2 and 3 comma 4 first.
Excellent job! Go ahead and figure out the rest of the boxes one by one. What was the coolest thing you learned from today's problem?
When I first looked at the 7 block by itself, I couldn't figure out where the numbers went. But after finding 3 comma 4 and 1 comma 2 first, I could fill in that whole block all at once.
So you were able to fill it all at once, even though it wasn't a sure block. How did you do that?
Because I filled in the boxes I already knew first. Blocks change because of the boxes next to them. If the boxes next to them change, we get fewer choices for the numbers.
Exactly! If the boxes around it change, the numbers that can go inside change too. So if we look at a block and can't figure out the spots right away, we don't need to give up.
Right? We just have to look around to see if there are any clues we can fill in first.